So we're going to talk about the antiderivative, or the indefinite integral. So it's kind of the opposite of a derivative. If I said, hey, give me the derivative of x squared, well, you would say, alright, let me drop this down, that's 2x. Okay, no problem, right? Well, the good thing about the derivative is you could use it to check the antiderivative. With the antiderivative, you kind of do the opposite. Instead of dropping the power down, you keep the power here, and you, instead of lowering it, you raise it. So you raise this to x to the third, and instead of dropping it down and multiplying by it, you divide it, so that's why it's the opposite. So instead of lowering the power, you rise it. Instead of multiplying it, you divide it. So this would be the solution. But the thing is, when you check it, you go, okay, let me drop this power down. Oops, sorry about that. 3x divided by 3, and then you lower that, that's x squared, right? That gives you back the original. So this is the antiderivative, right? Well, kinda. The problem is, what if you have this? X to the third divided by 3 plus 1. You take the derivative of that, that's also going to give you back this answer. And you do this for any constant, because every constant derivative goes to 0. So we can't really account for every constant, so instead of, putting every single number that this could possibly be, we call this, here, let me just fix that real quick. So antiderivative is this. So to represent all the constants, we say this is the solution. That's a plus sign. X cubed divided by 3 plus c. This c represents the constant of integration, so it's literally any, constant. So that's your solution right there. X to the third divided by 3 plus c. So we'll do some more examples. So we have 2 more problems here. Sorry, I didn't put this. Dx, that needs to be there. That is what we're integrating with respect to, so that needs to be there, or solve the antiderivative for. So, like you said, once again, raise the power, divide by that power that's being raised. So this would be 3. And then you just add the constant. So the solution to this is 2x to the third power divided by 3 plus c. Now here, same concept, raise the power. Now if you have a 1 here, or any constant, that doesn't go to 0 when you take the, like when you take the derivative. That goes to the variable. So this turns into x. Any constant turns into x. So that would be the solution for this. Don't forget the plus c, like I just forgot. Oops. But that's the solution for that. Sorry, the 3 is a little weird, but there you go. That's the solution for this. If you want to check it, you could check the derivative. You drop down the 3 here. This would be 2x squared. This constant would go to 0. Same thing here. This would drop down. This would be x squared. And this constant would go to 1. This could go to 0 and this would go to 1. So you could, that's how you solve the antiderivative, and you check it taking its derivative.